Okay, guys, here we go, day 6 practice day. So we've learned everything we need to learn in this unit, and now we're just going to put it all together and practice a little bit. So the first one, the recursive formula to describe a sequence is shown below. So let's just say this in words. This is our first term, 3, and then the next term is twice the one before it plus 1. And they want us to write the first 4 terms of the sequence. Okay, so the first term is 3. And now to get the next term, we're gonna do what it says. So it says twice the one before it, so twice 3 is 6, plus 1 is 7. And you just keep following that pattern. So to get the next term, it's gonna be twice the one before it, and then plus 1. Twice the one before it, and plus 1. So they gave us the recursive definition. It's not arithmetic or geometric because it's a combination. And then that's what the next question says. Can the sequence be represented using an explicit geometric formula? And the answer is no, because it is not just a multiplying pattern. All right, so that's a great Regents question that you guys could be good at. All right, next one. Write an explicit formula. Okay, so as soon as it says write an explicit formula, this is what's going through my mind. I'm thinking about, is it arithmetic or is it geometric? These are the 2 explicit formulas. The first one is arithmetic, second one is geometric, and they're both on the reference sheet. So I have to decide which one of those am I going to use. So let's see. The nth term of the recursively defined. Okay, so we can see that this is recursive. They're giving me the first term, and then they're telling me that the next term is the one before it times 4. So see how I just said times? So now we know that we're going to use the explicit formula for geometric. So a sub n equals the first term. The common ratio we can see is right here. That's what they're multiplying by, 4 raised to the n minus 1. And that's it. When I write a formula, when I write a rule, a model, there's 2 variables. Here's my first variable, which is y, and there's my second variable, which is x. Let's check out the next one. Write an explicit formula. So again, if we go back up to the top right there, I'm wondering which one of those formulas should I use. Now they're giving it to me again, recursively defined. Let's say it. The next term is the one before it times k. So again, it's times, right? They're multiplying by k. That's my common ratio. So a sub n equals a sub 1 times r to the n minus 1. A sub n equals the first term. So we have a binomial here, so we have to use parentheses, times the common ratio, which is k, raised to the n minus 1. This is how you have to write it. Got to use parentheses, and there's certainly no multiplying going on right here. Okay, this is it. That's the only way to write it. Okay, next. Just give me 1 second. I could let the dog out. Coco, come on. 1 sec, guys. Okay, the average depreciation rate. Okay, so that means this is going down to depreciate, is approximately 8% per year. So look, I know right away, turn this into a decimal, and because it's going down, it's going to be 1 minus 0.08. So my rate is going to be 0.92. That's my common ratio. We know this is geometric, okay, right away. Okay, if a new boat is purchased for $75,000, so there's my a sub 1. Which model is a recursive formula. Okay, so this is great because we can automatically get rid of some choices. And there's actually only one there that's in a recursive format. This guy right here, this is it. Look, the next term is the one before it times 0.92. Recursive always has the n minus 1. Look, these are all exponents. Those are no good, no good. You're never going to have n as your exponent with a recursive definition. So that worked out nicely for elimination. And I know some of you guys that love to eliminate without doing the work would love that question. All right. Especially period 7. Okay, when a ball bounces, the height of consecutive bounces form a geometric sequence. The height of the first bounce is 121, and the height of the third bounce is 64. My kitty cat is coming up here. To the nearest centimeter, what is the height of the fifth bounce? Okay, so this is one, remember where we have space between it. We want to find the common ratio, so we can't just do second divided by first. Remember, this is the one where we go backwards. We're still going to divide, but we're going to take the root of the difference between them. So we wind up with a common ratio after you put that in your calculator of 8/11. Okay, so if we want to find the fifth bounce, let me just make more space here. And it says to the nearest centimeter, right? Okay, so if we want to find the fifth bounce, look, we're at 3 right here. We can just sit there and multiply, okay? So if you multiply in your calculator 64 times 8/11, you get 512 over 11, and then if you multiply again by 8/11, you get 4,096 over 121, which you got to turn that into a decimal, 33.851, and then rounding to the nearest centimeter would be 34. Okay, so nice review question there. All right, number 6. So classic, on every Regents. Let's try to really be great at a question like this. So it says Rowan is training to run a race. He runs 15 miles the first week. I think we're getting good at this now, right? That's our A1. And each week following, he runs 3% more. So we know that's an increase. I'm sure right away now you're putting 0.03. You know that it's 1 plus 0.03. So my common ratio is 1.03. All right, look, this is what we did on the last lesson. Using a geometric series formula. Now that's on the reference sheet. S sub n equals A sub 1 minus A sub 1 times r to the n over 1 minus r. Find the total number of miles, total, right, summation, or this geometric series formula, that Rowan runs over the first 10 weeks to the nearest thousandth. Okay, so we're doing this for 10 weeks. Okay, the dog needs to come in 1 second. Come on. Okay, sorry. Okay, and so the first term, 15 minus 15, common ratio, raised to the 10th, right? Because whatever you're putting in for n goes in both places. 1 minus 1.03. We wind up with 171.95818. You guys have to round correctly here. We're going to the thousandths place. So tenths, hundredths, thousandths. I look 1 place to the right. If it's 5 or greater, I push it up, and it's not. So 171.958. Great question to be fantastic on every Regents. All right, here's another one. Brian, oh, let's pick a different color. We'll go purple. Okay, Brian deposited 1 cent into an empty non-interest bearing account on the first day of the month. So that's my A sub 1. Now, we have to be careful. The way we write 1 cent as a decimal is 0.01. He then additionally deposited 3 cents on the second day. $0.09 on the third day, and 27 cents on the fourth day. What would be the total amount of money? All right, so total again, that we would have on the 20th day. So you don't want to sit there and keep going until you get to the 20th day. So let's find the common ratio. Second divided by first. The common ratio is 3. And then we could just use our geometric nth partial sum formula. So S sub n equals A sub 1 minus A sub 1 times r to the n over 1 minus r. So we want to find the 20th first term minus the first term times the common ratio raised to the 20th all over 1 minus the common ratio. Throw that in carefully. And there we go, choice 2. Okay, one more. All right, Jake wants to buy a car and hopes to save at least $5,000 for a down payment. The table below summarizes the amount of money he plans to save each week. Based on his plan, which expression should he use to determine how much he'll have saved in n weeks? All right, so let's take a look at all these choices. If we look at all of them, they all kind of look like they're in the form of the nth partial sum for a geometric series. So let's write down what the correct formula is. And then let's plug in our own values, and then we'll see which answer matches. All right, so week 1 he has 2, week 2 he has 5, week 3 he has 12.5, and so on. So this does seem to look like it's geometric, and also all 4 choices are in the form of geometric. So let's find the common ratio. So be careful, you're using 5 and 2, going backwards. So second divided by first. So my common ratio is 2.5. And let's plug into our formula. So S sub n equals the first term minus the first term times the common ratio raised to the nth power 1 minus your common ratio. And looks like we got choice 1. Alrighty, so that's all you have in your packet, but I have an extra question that I want us to do. So I'm going to have you write this one down. I'm just going to erase some of this to make some space. Oh gosh. Nope, okay, it's not going to let me erase. Okay, so I'm just going to write in my question here that we're going to do. All right, here it is. I'll just go like this. All right, solve for x in simplest form. Okay, so this is just an old review question that I'm going to put on this test. Solve for x in simplest form. So hopefully we notice that this is a quadratic equation, right? So we know we want to set it equal to 0. And again, like, see this pen, I guess eventually it decides it doesn't want to change color anymore. So we're going to add 20 to both sides. And now we have 6x squared minus 8x plus 20 equals 0. Very first step always in solving any kind of quadratic is taking out the GCF. So let's take out a 2. I'm left with 3x squared minus 4x plus 10 equals 0. From here, we'll try to factor 3x squared minus 4x plus 10, but if we try to factor it, it doesn't work. So now we're going to set each factor equal to 0. And this guy, we're going to have to use quadratic formula. Okay, so A is 3, B is -4, and C is 10. So I will put this review question on your test. All right, remember what the quadratic formula is? Sorry about the saving image thing. I don't know. It just gets crazy after a while. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we're going to have -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, my space is so limited here, and it won't erase, so that's just lovely. Okay, I'm gonna have to move up top, like to a spot that I can find. So pause it if you need to write that, but I can't go down anymore, so I'm gonna have to go, hopefully I could go back up and find some nice space. Oh, there's some space. Okay, great. All right, we'll use this. Okay. All right, so at this point, clean up the bubble inside the radical there, and we're left with x equals 4 plus or minus the square root of -104 all over 6. Remember, you can't reduce that 4 and 6, right? There would have to be a number on the outside, the radical, to reduce. So let's break this down. Largest perfect square that goes into 104. Remember, you guys can always go in the calculator, do 104 divided by x, and then go to the table and find the largest perfect square. 4 happens to be the largest. Okay, so this winds up being 2i rad 26, and that replaces the negative rad 104. We'll go over here. So x equals 4 plus or minus 2i rad 26 over 6. Okay, so now we can do, I wish I could change color, but it just doesn't want me to. I can do my 3 circles, GCF, and we're left with 2 goes into all pieces, so 2 plus or minus I rad 26 over 3. Okay, and that's it. If it had said simplest A plus BI form, if it had said that, then you'd have to separate. Remember, x equals 2/3 plus or minus. And then it could be written many ways, but we could put rad 26 over 3 and put the I right next to it. That's if it said simplest A plus BI form. Okay, guys, so that was the practice day. If you need to, watch the video again, do the questions again. That's really the best way to do all this. All right, bye.